Okay, so this is the last unit of the calculus core unit, and I was going to skip it, but I was like, no, 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 this is important. We have to talk about this because, my goodness, because some of these questions are different than the way I had them when I was a kid, when I was taking calculus, because I didn't have technology. So let's just go through these first couple of problems. May seem obvious, but I just want to talk about a couple of things with the later problems. So the first question is find the maximum value of f, which equals x1 minus y, given that x plus 3y equals 7. So you would say, okay, I got this. You're asking us to maximize f. And so you're going to take the first thing you should think about if you hear max or min of a function is take the first derivative, set it equal to 0, solve for x or whatever variable it is, and then you can either do you can make a sign chart or you can plug the value into the second derivative to determine if it's a max or a min. The first issue here is we have more than one variable. This is a high school calc. It's a univariable, one variable calculus. You have to get rid of those variables. You might see this in the volume of a cone when you have radius and height. So volume is a function of radius height. You're given another relationship that allows you to eliminate one of those variables. So let's eliminate x. So we have x equals 7 minus 3y. That allows us to have a function f solely as a function of y. They're just letters. So we have 7 minus 3y times y minus y. Let's expand this out. We have 7, so it will be 7 minus 3y times y, yeah. So it's going to be, 6y minus 3y squared. And we want to find the maximum value. Let's take the derivative. So it's 6 minus 6y. Set it equals to 0. It's clear that y equals 1. We want to determine if this is a maximum or a minimum. Let's plug it into the second derivative. The second derivative is equal to 6 minus, the second derivative is negative 6. Therefore, it's always less than 0. Therefore, it's a max. The second derivative is always 6. So it's probably like, this is a parabola. It's a frown. We know it looks like this. So this is clearly a maximum. Y equals 1. Y equals 1. That means, let's see, so y at 1 is a max. So that means x equals 7 minus 3, y is 4, and therefore we can solve for f. F is equal to, what was the original function? 4 times 1 minus 1 with 3. So the maximum value of f, which equals xy minus y, is 3. Basic. Okay. Let's take a look at this next problem. A rectangle has a perimeter of 100 centimeters. What is the maximum area? So you're, okay, so they're talking about a rectangle or a shape. I'm going to draw a picture. I have two sides, x, y, maybe you want to write the other x and y, and we want to maximize the area. That's when you're looking for the words, maximum area. Okay, so you're like, fine. A equals xy, I need to maximize that. But once again, we have two variables. Once again, you're going to get many equations with multivariables. For example, the volume of a cylinder is a function of radius and height. But we can eliminate that. Are we given another condition, another constraint? Like in the previous problem, remember it was like we were told that x plus 3y equals 7. Do we have another constraint? Yes. We're told that the perimeter, which is 100, the perimeter is 100. Well, what is the perimeter is the sum of the sides, which is 2x plus 2y. So we know that's going to go in there. And once again, it's very straightforward. You're going to see problems with fences along the barn, and there's this amount of fence, and you want to maximize the area, or you have a stable and you need to put two fences in between, and you have 300 meters of fence. It's just you're maximizing the area given the restraint of perimeter. That's fine. So that means that 50 is equal to x plus y. Let's set y equals 500 minus x. Stick it in the area formula. So we have x times 500 minus x. The area is 500x minus x squared. The computer's on, right? Yeah. And, you take the first derivative. First derivative is 500 minus 2x. While we're at it, so once again, you set it equal to 0. And we have 2x equals 500. X equals what? 250. Is that right? I made a mistake somewhere. Oh, I'm sorry. Here's my mistake. 50, 50, 50, 50, 50, 50, 25. X equals 25. Good catch. So anyway, x is 25. You already know, once again, at this point, you're higher level kids. You know that the second you saw that the area was a frown, you know that it's going to be a max. Once again, you know this looks like this. You know there's a max. So x equals 25 is a max. Just say that, the second derivative, is -2. It's less than 0. So this is a max. IB wants to see that, and that's fine. If x equals 25, then we know from our formula y equals 25, and therefore the maximum area is 625 units squared. That's fine. The book actually talks about this on page 676. It's called these are called an isoparametric problem, in that to maximize a rectangle is a square. It's kind of cool, but once again, same problems. I want to talk about the next two problems, because they're part 2 questions, and they seem straightforward. You need to recognize this. So let's just talk about this for a second. So take a look at that problem. It's right out of the book, and the question is, find the point on the curve y equals x cubed closest to the point 2, 0. So you're like, okay, it's a distance problem, and we want to minimize the distance. Closest to. So we want to minimize the distance. Okay, so let's assume it's not a part 2 question yet. So you're making a graph. I'm making a section. You know what? I'm a higher level student. I can sketch this. I have an idea of what's going on here. And it's the point 2, 0. Okay, and so I know this point on the curve is xy. And so I'm going to find this distance between the 2 points. So you say, fine. You know the formula is the distance is the square root of, and let's go from the point on the curve to the point 2, 0. So it's x minus 2 squared plus y minus 0 squared. Now, the idea is I'm going to take the first derivative, set it equal to 0. So looking at this, I have 2 variables. Is there a way to get rid of that y? What is y? Well, anyone? Yeah, good. Y is x cubed. So we actually have, so it's d equals the square root of x minus 2 squared plus y to the 6. X to the 6. Okay, so the thing is, so we would take the first derivative. So let's expand this out. Sorry. We have the square root of x squared minus 4x plus 4 plus x to the 6th power. And so what do we do? What do we do? Well, we take the first derivative, and it's 1/2, open parentheses, x to the 6th plus x squared minus 4x plus 4 to the negative 1/2 times 6x to the 5th plus 2x minus 4, and we set that equal to 0, right? Now, here's the thing though. You don't have to do this if this is a calculator problem, right? Because what am I trying to do? Once again, I'm trying to find the minimum. So if this is a part 2, all you can do is just literally find the minimum of D. And what you're going to do is go to your graphing calculator. You're going to go to your graphing calculator, and you're going to go to your graphing calculator. Let's see. Graph, tab. You're going to put this function in there. So you put the square root. You're going to put the square root of, this function. Let's see. You're going to put this function in your calculator. It looks like this. Can you see that? I put the whole function in there. It raises to the 0.5 power. And that point is the minimum value. So you're going to do menu, analyze graph, minimum, and we know how to find the max and the minimum. Yeah. Graph. Graph, the lower bounds. Let's see. The upper bounds. There we go. And the calculator tells us the minimum is 0.829. The minimum x value is 0.829. So is that right? Yes. The minimum. So the idea is that once you get a function, if it's a part 2 question, just literally stick this graph in. It looks this graph looks like this, and then just find the minimum value. That's the minimum x. Can you see that? Yeah, that's the minimum x, and that's your answer. So I don't want you to get, for those of you who I have to do it without, no, take a step back and say, you know what? It's a part 2 question. That's difficult. I don't know how to solve x to the 6th power unless it's in one of those questions where it's like, use the rational root theorem or use systematic division. Use a calculator. So you have a distance. Here's your function. Plug it in the calculator. Find your minimum value. Find your x. Find your y. Find your x, and then your y is 0.829 cubed. And that's the answer. That's how we're going to do this problem. Now I want to talk about the last problem. Once again, I didn't really think I want to talk about this, but so it seems the same, right? It seems the same, but let's assume this is a part 1 question. It is a part 1 question because it's actually the hardest question. It's question 13. It's question 13 in the book, and it's a non-calculator question. So I want to go through this. Find the coordinates of the point on the curve y equals x squared, where x is greater than 0, closest to the point 0, 4. Fine. I'm going to make another graph, but in this case, I'm not going to do the whole parabola. I'm just going to take x equals 0 because I was told that x is greater than 0. Fine. And here's point 0, 4. Good. And I want to find the distance from this to x. And I'm going to take the next step. Instead of writing xy, I'm going to eliminate my restraints and write it as x squared. Fine. Now, you say, okay, I can figure this out. I know the distance between 2 points is, and I'm going to start from my x squared and go to 0, 4. And I know it's x minus 0 squared plus x squared minus 4 squared. You say fine. And then you go through the motions and you see x squared plus x to the 4th minus 8x squared plus 16. Clean this up a little bit, and you have x to the 4th minus 7x squared plus 16. Okay, now here's the thing I want to bring up. You all have the answer book, and you look in the back, and they don't take the d function. They do d squared, and I thought about it. Don't I have to take the first derivative of d? And the idea is no. So let's work through this, and then just discover the fact that we don't have to, we can just leave it, we don't need this radical. So let's assume we're going to leave the radical. We're going to take the derivative. So it's 1/2 of x to the 4th minus 7x squared plus 16 to the negative 1/2, which means this is going in the denominator, times the derivative of this, 4x cubed minus 14x. Well, this isn't so bad. This is why it's a part 1 question, because we can solve this. So this is then equal to 0. Now, let me rewrite this so you can see what's going on here. We have 4x cubed minus 14x all over 2 radical x to the 4th minus 7x squared plus 16 equals 0. Now, how do we get a fraction t equal to 0? How do we get a fraction t equal to 0? Well, yeah, if the numerator is 0, then we don't care about the denominator. We know this is not going to be equal to 0. And we just want the numerator to be equal to 0. Now, so you have 4x cubed minus 14x equals 0. Pull out 2x. So you have 2x squared minus 7 equals 0. Right? And so we have x equals 0. Can x equal 0? Maybe. Or what else do we have? We have x equals the square root of 7 over 2. Okay. And then you say, okay, well, we have to test it out. So here's where I'm going to stop. I'm going to introduce something, a new idea. Maybe I don't need to find the distance. Maybe I can work with the distance squared. Maybe I can work with distance squared. So you know what? I'm going to stop. I'm going to stop here, and I'm going to backtrack. Because I don't want to take the second derivative of that. That's just, I don't have time for it. I'm a higher level student. It's not a calculus, but I don't have time to be doing all that work. Is there an easier way? Yeah. So you know what? Use d squared. X minus 0 squared plus x minus 4 squared. It's a function. And you know what? If you get confused, pull the letter out. So I don't know, c equal d squared. Or call it big D or whatever. So we're going to call this c. I want to maximize c, which is my distance squared. It's not the second derivative. It's not. It's just I didn't take the square root. So that's my function. Okay, so I have, this is x squared plus x to the fourth minus 8x squared plus 16. I know that c is equal to x to the fourth minus 7x squared plus 16, right? Let's see what's going on here. Well, the first derivative is 4x to the third minus 14x, set that equal to 0. We already saw that over there. 2, 3, 4, 5. We saw that over there. Let's pull out a 2x. I got 2x squared minus 7 equals 0. 2x equals 0. 2x squared minus 7 equals 0. And if you're a good math student, you know what? Skip this. Just so you know, x equals 0, and you know, you're like, okay, you know what? X equals 7 over 2 radical 2. Why am I skipping this step? Because, well, we got the same answers. We got the same answers. Let's see what's the next thing we have to do. I have to take the derivative. I need to, what's a faster way? Well, you know what? What's the second derivative here? 12x squared minus 14. Now I'm going to get the same thing over there, but this works. This works. Keep the squared. You don't have to deal with all those radicals. Low d high minus high d low. No, I don't want to deal with all those radicals. So what's going on here? If x equals 0, I have negative 14. This is a max. If x equals the square root of 7 over 2, what do I have here? So it's 12 times 7 over 2 minus 14. What's going on? Yeah, I'm sorry. I'm sorry. That's totally fine. Yeah, this is, I'm sorry. 42 minus 14 equals 28. Therefore, it's greater than 0. Therefore, this is a maximum. This is a maximum for d squared, for c, which is the distance squared. That's the distance squared, and the idea would be, and so what we can conclude, sorry about that, what we can conclude is, if we have a minimum for c squared, if we have a max, sorry. Because when we plugged in radical 7 over 2 into the second derivative, we got a positive number, which means this is a minimum for c, which is the distance squared. Therefore, and you're allowed to conclude this, therefore, radical 7 over 2 is a minimum for distance. And that's the idea. So, henceforth, in these distance from curve problems, set up the formula, and if it's a part 2 question, you can use put the function of the square root of the distance, put that in the graphing calculator, find the minimum, or leave it as d squared, take the first derivative, set it equals 0, find the max for the distance squared, and then you can conclude that that's the minimum. You find the minimum for distance squared, and then you can conclude that that's the minimum for distance. Thank you.